I'm Nicholas Di Lorenzo, a mastering engineer, and this was my second time building a studio space. And I'm going to show you what matters, from acoustics to dealing with supplies, bad purchases, and staying sane when everything feels like it's falling apart. And we're going to break this down into 4 parts: design, logistics, the build process, and the results. So whether you're building from scratch, retrofitting a spare room, or just dreaming about your future space, I'm sharing my experience here to help future me out and you. Let's start with the question that kept me up at night. Is it better to retrofit a space or build from scratch? And to answer that, I asked myself 2 things. What were my goals, which I mentioned, and also what's my tolerance for pain? Because here's the truth. You can absolutely retrofit a room and get a great result. When I was putting up the installation for this space, I was taking progressive tests, and 80% of the acoustic performance in this space came from one thing: broadband absorption at the first reflection points. And that could have been as simple as hanging panels on the existing walls. But I think the key takeaway from this is, when it comes to the treatment of the space, your first reflection points are your highest return on investment. And I could have stopped there, but I had a vision. I wanted this room to be bespoke, visually clean, acoustically invisible. So I built out a full frame, recessed my diffusions, cable runs behind the walls galore, and even added a reveal in the ceiling so I wouldn't see the curtain rails. And why would I go to that plus many other efforts? Because I've worked in many studios that feel messy: bulky furniture, mismatched racks, random acoustic panels floating everywhere, and it's got its charm and it serves its purpose, and my past studio was similar to that. But I wanted something different. I wanted a room that felt like a living space, inviting, clean, and everything totally integrated. Now, I gotta admit, I changed parts on this studio build pretty late in the journey, because I visited Just for the Record in LA, and I was really inspired. Each room felt like an architectural digest feature where form followed function and the vibe matched the precision. Even the bathroom, okay, just going to the toilet, the fittings and everything, the way it was all designed was immaculate. So that's what I chased. Not just a room that sounded good, but a space that reflected how I work and would make people feel comfortable the moment they walked in. So knowing that we're building it from scratch, or if you're retrofitting a room, you're probably asking, what's the ideal room size for accurate monitoring and mixing? Because that's the ultimate function of any mixing and mastering room. And there's no one size fits all answer, but here's the process I use to land on my dimensions and the key lessons I learned along the way. Now, this studio is part of my home, but before the house was built, I had a unique advantage. I could still adjust the length and width and the height in the drafts, so to make those decisions, I used a free tool by John Brent. It's an Excel spreadsheet I'll link below, and in that spreadsheet, it calculates your room modes, but you can also sort your room modes and see if there are any near incidental modes, so 2 modes that are close together. Now, my goal was simple: design a room where the modal distribution, the way low frequencies resonate, was evenly spaced as possible below Schroeder. Now, every room has modes, frequencies that build up based on the room's dimensions, and there are 3 kinds of modes. There are axial modes, which is between 2 parallel surfaces, so your X, your Z, your Y axis. There's tangential modes, so modes that operate between 2 axes or 4 surfaces, and oblique across all the axes and 6 surfaces. Now, as you go higher and higher up in frequency, those modes stack up exponentially. Eventually, they're so tightly spaced that they blur together and behave more like directional rays. Now, that transition point between where they sit as static waves and move as rays physically is a point called Schroeder frequency. And below that is what's known as the wave region. Above is the ray region. Below Schroeder is defined as static pressure zones. Now, you've experienced this if you've ever played a low frequency sine wave and walked through a room. To hear it peak and dip, you're actually walking through static pressure zones that are fixed within the room. And this is where modal planning makes or breaks the room. This is where understanding how your dimensions and where there are near modes, like modes that are too close together or too far apart, which I learn about later, how that affects the balance of the room. So The ideal room is one where they're evenly spaced with the least amount of near incidental modes, and the mistake I'm going to tell you to avoid is stay away from cube-shaped rooms or any layout with matching or doubled up dimensions, because anything that are multiples of one another in length, also multiples in pressure or frequency, and that can cause big build-ups of particular room modes or big nulls in your room. Now, that all said, I thought I had this all nailed, until I had a call with Yesko from Acoustics Insider, and he pointed out something I missed. It's not just about spacing and making sure modes aren't too close together, but you also want modal support in every third octave band.
You did a decent job. Unfortunately, it could have been better. Yeah, it's not the end of the world. Let me just show you what the issue here is. It's not. It's one of many small things. It's not going to be a deal breaker, but it's just one of the issues with this, right? So, what you basically want to do, ideally, is get a consistent increase of room modes as you go up in third octaves. Yeah. And so at the moment, you've got a hole right here.
Yes, I know.
Yeah.
I did realize that.
Yeah. So this is between 33 and what is the other one here? 47 and 48 hertz. Yeah. What will happen if the room actually gets excited in the low end? Yeah, which ideally shouldn't happen with the drywall. But if it does, what will happen is that in the untreated version of the room, you will actually see a lack of energy in the low end in this frequency range. Yeah.
Okay.
Because the idea is to get kind of room mode support.
On paper, this was a problem, and while it eventually worked itself out in the build and didn't become too much of a dip in the final response, I would have addressed it earlier if I had known. This is your cheat sheet, okay? Use John Brand's calculator to set your length, width, and height, and check how the modes stack up next to each other. Make sure there's no near incidental modes. In doing that, avoid dimensions that double up or are too similar. Avoid near incidental modes below Schroeder. Confirm modal support in every third octave band using an AMROC calculator. And that's pretty much what I did, except the last step, which was sort of an oversight on my end. Ultimately, and we'll look at this later in the video when we look at the results, my room responds plus minus 3.75 dB down to 27 Hz. And at a third octave band at 50 Hz with an impulse graph, there is a decay time of under 350 milliseconds, which is very solid. Once I had my room dimensions locked in, the next question was, what do I actually need to prioritize to make this sound incredible and function seamlessly? Number one was speaker placement. Now, there's a ton of conflicting advice out there, especially about how close you should place your monitors to the front wall, but here's what worked for me. In small to mid-sized rooms, moving your speakers close to the wall can raise the speaker boundary interference reflection frequency. I'm going to call that SBIR from now on, and that makes the cancellation, the higher that frequency is, easier to manage with broadband trapping. The further away speakers are from boundary surfaces, the lower that SBIR frequency becomes, and the longer that wavelength is, the more difficult that reflection is to manage. So in a perfect world, you'd go soffit mounted. That's where the speakers are mounted into the inside of the wall, so the face of the face of the driver is in line with the whole wall array. That's the gold standard. It eliminates SBIR from the adjacent walls, but after spending 12 years in a studio with no natural light, I wanted windows. So that meant no soffit mounting. Compromising with this and putting the monitors as close to the wall as physically possible, it still measures exceptionally well. Perfect world, you wouldn't do that, but I want to spend a long time in this room making records, which means I want to have some natural light. And it's as simple as that. A key takeaway, if you're in a small to mid-sized room, don't be afraid to put your monitors to the back wall. Obviously, don't block up any ports if you've got ported speakers, but it will help a huge deal. In addition to speaker placement is listening position. For that, I started with the 37.5% rule, or 0.375 or 3/8, and it suggests placing your ears at 37.5% of the room's length from the front wall. Now, why? Because that usually avoids the worst of the axial mode cancellations between the front and back walls along your x-axis. And I'm going to show you what this looks like in Room EQ Wizard. So here in Room EQ Wizard, we've got a room simulation. here, which we're going to look at. But before we do, I want to show you this graph here. Now, this left side here is my front wall. This right side here is 5.2 meters back my back wall. This is the first axial mode at 33 hertz. At half the room's length, it has no pressure. It is at complete equilibrium with itself, because when it phases back, it cancels itself out there. At the far ends of the wall, it builds up in pressure, and with the second axial mode at the very center of the room, it has the most amount of pressure. It will actually resonate, that second mode in the center. Now, the reason why we say 3/8, okay, is because there's equal balance between the mode's pressure at the first, second, and third mode. I haven't got the third mode plotted out here, but the first and the second mode are equal pressure. If we have our listening position at a quarter of the wavelength, that second mode is in complete null, whilst there's a high pressure on axial mode 1. So what we're going to do is we're going to look at a quarter, a half, and 3/8. Okay, so a quarter of 5.2 meters is 2.6, 1.3. So here what we're going to do is, let's take this little head here and bring it to 1.3 meters. And what we can see is that second mode at a quarter length, okay, a quarter length is in complete null, whilst that first mode is as a high pressure zone. Now, if we go halfway into the room, which is 2.6, let's go 50%. I'm just going to zoom in here. 50%. Okay. If we go 50%, that axial mode 1 is a complete low at zero pressure. Okay. It's not at a high pressure at all. Zero pressure cancelling itself out. And that second mode is at its highest pressure point right in the center of the room. So you get a big resonance there at 66 hertz. Well, what happens if we go 3/8 of the room, which is roughly 1.95? Let's go there. 1.95. There we go. Well, what's happened to our first, second, and third modes? They're all of equal or relatively equal power. 99 hertz, 66, 33, all of equal power. And that's in the room simulation. And when we look at the actual graphs, you'll actually see how this translates into the real room. So as you can see, shifting your listening position dramatically changes the low end modal response along that x-axis. And that said, this only optimizes one axis for the listening position, and obviously you want to be in the center for the stereo image, but that low wavelength, okay, so the length of your room where you have the lowest modals or lowest modes in the room is really difficult to manage with treatment. So getting them evenly distributed is really important. I actually got a little bit of blue tape on the blue painter's tape underneath my mat for my chair, so I remember exactly where that listening position is in case I ever wheel my desk forward or back. I know exactly where to plonk my head. Now, use it as a starting point, but also measure and trust your ears before you lock it in. So that's important. So we've got speaker position, listening position. The third priority was first reflections. You have to treat them all, the side walls, the ceiling, the rear wall, and you're going to be surprised, and I surprised myself with this, the floor. This is where my ego got the better of me. Both Ed Thorne and Drew from Warp Academy warned me about floor SBIR issues. And when I was doing my tests, I was finding this weird null at 140 hertz, which is exactly where they had told me about, but I brushed it off because it just sounded arbitrary, like an arbitrary frequency. How can it be that? Anyway, I started ripping insulation off the wall, putting it on, like just throwing it around, doing test after test, and eventually that 140 hertz null went away. Let's go 69 to 61. I got an 8 decibel improvement by putting insulation on the floor, which is annoying because now I've got to build out 2 boxes, one in front of the desk and one rectangle that's going to sit on the floor in front of my desk, and 2 little squares which will sit on the floor in front of the speakers. And that's sort of what I got jigged up in front of me to deal with this floor bounce. And that's why this measurement up the top deals much better. And what it actually did was, it went away when I'd thrown insulation off the walls and onto the floor. So with that happy accident, quote unquote, even though I'd been told it before, I built some custom floor absorption boxes, put casters on them so I can roll them around, and now I have this ugly eyesore on the floor, which makes everything sound better. my mistake to avoid for next time is to not overlook vertical reflections. If your floor's reflective, your low mids are going to pay the price. My next priority number 4 of 5, was infrastructure and provisions. Beyond acoustics, I wanted to future-proof this space, so infrastructure was huge. I pre-wired for Dolby Atmos, so 7.1.4, added Cat 6 cabling to all of those positions, cabled two sets of 4 audio lines to each front wall, so the left and the right. I put a dedicated circuit breaker just for the speaker and the audio equipment, and all of it's wired to the rear wall where I can patch everything across, and none of this is glamorous, but all this stuff makes the studio work day to day, and it's without headaches, because right now I'm recording a video for YouTube. There's no cables sprawled across my ground. I'm just patched into the wall, into an interface in the back wall. No stress at all. So when you plan your wiring, plan like you're building a network, not just a room where you have to get speakers and mics. Think of it as like a full network that can be interlinked. Plan for redundancies before you start building. And I'm going to be honest, I didn't do this in the planning stages, and it cost me so much time ordering more spools of cable, waiting, rebuilding panels, tearing apart patch panels I had put together and resoldering them because I was changing my mind mid-build, and that slowed me down a great deal. And last but not least, I cared about how the room felt, and that was finishes and aesthetics, which meant testing flooring, fabric, and finishes before locking anything in. For the walls, I used Zeppel's Jupiter line of wall fabric. It's flame retardant, polyester, and 3 meters wide. It's to Australian standard as well, which is really important for me. 3 meters wide is important, so there's no seams. It looks clean and professional, but it was so difficult to work with. I had these small samples they sent out to me to judge from, and they were cool because I got to see the color, but I couldn't judge the stretch of them. My previous fabric I used in my last studio was so much easier to work with. It had a good stretch to it. So make sure whatever fabric you get has a bit of stretch to it. For the timber finishes, the slat walls, I had 2 choices. Tasmanian oak in a natural tone or pine, which matches my side rack and the back diffuser, or pine with black UV stain. So it's a exterior UV stain I've applied to it, and that basically means it's not going to weather with any UV or sunlight coming in from the window. My wife suggested going with the black, so there was a stronger contrast against the fabric, and I'm happy I did, because I think it would have been too much timber in this room with the floorboards and the desk and the side rack if I'd added more timber into the slats. For the flooring, I went through about 5 samples and ended up with this European oak, which also matches the house tiles nicely, so the room doesn't feel too jarring. The XLR panels I custom made to match all the clips or light switches and power points, and I ended up reordering it all because I originally made those with silver XLR patch panels, and I'm like, wait a second, I've got black slats and all black fittings in this room. I want black XLR patch panels, so that was a whole new rebuild. So let's recap my priorities before we move on with this video. Accurate speaker placement, number 1. Correct listening position, number 2. First reflection points, number 3. Future-proof your wiring and provisions, and then aesthetics. Now, let's get into the logistics. Why is building a studio always 2 times more stressful and expensive than expected? I could build this studio in 2 weeks. I had a spreadsheet, I had a plan, and I figured, hey, I know audio. How hard can it be? But here's the brutal truth. Building a studio is always at least 2 times more stressful and expensive than you expect because, and this is the big because, planning a studio happens in spreadsheets, but building one happens in reality. In theory, it's all clean and easy, models in SketchUp, totals in Excel, but when it's time to build, you're shaping raw materials into a functional, creative space. And when something doesn't go exactly to plan, and that will happen, my stress level wasn't determined by how well I had planned, but it was by how well I could adapt. And to be honest, I didn't adapt all that well sometimes, and sometimes I actually surprised myself. But here's what I learned the hard way. Audio engineers are not builders. I love carpentry, but I'm not a builder. And that meant every small hiccup came with a learning curve. From framing, to joinery, to supply delays, to supply quality. All of it has rules that don't care about how great I can make a record sound. And the second thing, Everything takes longer than it should. What I thought would be a 5-minute online order ends up in a week-long, 2-week-long detour. Like I said before, I couldn't find wall plates that match my light switches for the XLR, so I bought blank face plates, drilled out the holes, tapped the mounts, and then realized the silver connectors didn't match the aesthetic, so I bought them again in black, and this is the kicker. I didn't say this before, but just as I was about to fit them off, I remembered I run Cat 6 to every speaker position. And if I ever wanted to patch into those Cat 6 cables with an RJ45, I'd have to undo the whole panel, unsolder the XLR, and refit the RJ45. So, what did I do? I started again. I made new panels with 2 blank provisions to future-proof that plate so I can fit off RJ45s without touching the XLR. And just like that, one problem turned into 3 or 4 problems. Not because my plan was bad to have all these speaker positions and cabling, but because each step reveals a layer I didn't consider. And that's the third bit of it, or lesson. There's hidden complexity everywhere. Take the speaker wall plates, as in these little wall boxes I got over here. It was going to be like the left, center, surround left, and then so I had these little plates to make up for those cables. And then I'm like, well, wait a second. I want to add 4 extra lines to each point for patching and running inserts and whatnot. So I can't use these little plates I'd got on. And what ended up happening? I have all these cables I have to put on the wall, and I don't want a bulky wall box sticking out. So I had to repurchase floor boxes and recess them in the wall, which means more framing work, more fiddling around and fitting off. And that had to happen. Then there was that rear cabinet. I framed it out underneath the diffuser at 19 inches wide. So the frame for the diffuser that the diffuser sits on, framed that out 19 inches wide. I forgot about the door access. Didn't think about it, but fortunately I had an old glass door from a TV unit at my parents' house. It was just a pane of glass, and I repurposed it, built a shaker door out of it, and put a push to open panel there. It's clean, hidden, and completely unplanned. But again, another step, another delay, another process. So the key insight there is studio builds are more like sculpture than they are spreadsheets. They're physical, iterative, and in constant flux. And I haven't even touched on cable routing. Halfway through the speaker runs, I doubled up lines. Why? Because I can. Logistics. If you think it'll take 2 weeks, budget 6 months. If you think it'll cost $10,000, plan for, well, much, much more than that. But most importantly, budget your energy. It's not just about the money or the time, it's about keeping your head together. And I can tell you, I lost a few marbles during this process, and budgeting your energy is really important. And that brings me to the next thing. Budgets for a studio build. How do you budget when everything costs more? And I'm not the person you should ask about budgeting, because I went well over mine, but that's exactly why I've got some hard-earned lessons you can use. Learn the difference between indulgence and infrastructure. And this came to me halfway through the build. I started splitting every expense into 2 buckets. Indulgent spending, stuff that makes your space look and feel amazing, but doesn't help it work better. A custom flush door, a PowerPoint fittings from Buster and Punch, which would have cost me thousands of dollars. I'm happy I didn't do that. The European oak floors, I did do, but that was sort of a luxury. It's not necessarily a function of the space. The recessed sheer curtains, again, it's more a luxury, not a function of the space. I wanted to get $500 door handles for the main door. I didn't need them. I absolutely did not. And that would have been a waste of money. So I didn't. So that's indulgent spending. But then you've got infrastructure investing. Stuff that makes your studio functional. The stuff future you will thank you for. Cat 6 Ethernet throughout. Extra XLR lines and Toslink lines and fiber optic runs and additional power points for every speaker, a central patch and control panel, and these expenses don't look exciting because you don't see them. They're hidden inside the wall, they're hidden inside a cabinet, but they're what separates a studio that looks nice from a functional one. Lesson 2, add a contingency buffer. I didn't, and I should have. More? How much more? Just more to your total budget, no matter how confident you are, because you will forget things. Glue, extra hardware, extra cabling, nails, brackets, tools you didn't know you need, like this long nose stapler for hard to reach places. I had a pneumatic stapler, but I wanted a long nose one because I had some interesting corners to get into. This stuff doesn't show up on your first budget spreadsheet, but it's going to show up on your bank statement. Lesson 3, budget for your time. I planned this as a 2-week build, and spoiler alert, it took months because I was working around sessions, chasing materials, dealing with supplies, and solving 1,000 micro problems. So don't just budget money, budget mental bandwidth, because when you underestimate that, things just get chaotic fast. How do you set realistic timelines for finishing a studio build? Because I was completely unrealistic about mine. I never paused studio work. I had 3 young kids at home, and I quickly realized this was not a 2-week project. This was going to be a slow motion marathon. Well, there are 3 things no one talks about, and they controlled my entire build. Number 1, storage space for materials. When I ordered the timber frame, that's all I could store in my corridor because I have a car in my garage. And I waited to order the insulation because I didn't really want that in the corridor where people are coming through. So I had to wait until the cabling was done in the studio. And then I ordered the insulation, put the insulation in, and the same thing with the flooring when I got the floorboards in, the slats for the walls, the skirting boards, fabric. I couldn't bring them in until I was ready to install them. I couldn't order them or have them here because we live here and there was simply nowhere to put them. So a key insight, if your house doesn't have a warehouse space or a big garage with extra abundant space, your build is going to happen in small sequence deliveries, which means delays are inevitable. Now, the second thing to the logistics of managing your time is when you're actually free to build. Most of the time I was working nights and weekends, and you can't run a drop saw at 10 p.m. in a residential area. If materials didn't arrive during the week, I'd lose an entire weekend to smash out work on the build. And there were so many times where a missing part or late delivery meant a full week's delay. But every now and then when my wife and I could get the kids to my parents or the in-laws, it was game time. 12 to 14 hour days of sanding, painting, fitting off, wiring. We made serious progress in those bursts. It just wasn't enough to undo every delay. So your build timeline isn't just about how long it takes to build, like the time on site doing things. It's about those 3 things: when you're free to work, when materials show up, and whether you've got space to store them. And when any of those break down, your whole schedule will shift. So no, I didn't finish this in 2 weeks, but I did finish it without pausing my client work, without turning my house into a complete construction site. There was definitely stuff around, and I didn't lose my mind completely. So that's the logistics covered. Now we get to talk about the fun stuff, the building process. Before I could do anything in the studio, I had to finish building the house, which took 2 years. Once it was done, the first thing I did was test this raw room, and you can check that video out here. I wanted to see if the room modes I calculated during planning lined up with the actual space. And it turns out, guess what? They did. Not only were the modal frequencies accurate, but the energy distribution across them was even too. Except for that odd dip around 80 to 90 hertz, which sorted itself out. So, step 1, before you commit to build a plan, test the room's raw response, both in simulations and in reality before you start putting walls up. Second thing is, with the testing done, I ripped out the carpet and got to installing the diffuser, which is a beast. It weighs well over 100 kilos, so I had to install it on a custom platform I made using double laminated studs that transfer the load directly into the slab. That is a structural overkill. I reckon you could fit 2 diffusers on that frame I made, but it was necessary because once that was in and the timber arrived, it was go time, and I really wanted to make sure that was solid, like it was not moving. And we got this whole frame up in a day with the help of my uncle and my dad. We got on the tools and it was done in a day. It was a good day's work. And from there, I started running cabling and electrical. Now, this is where it all doubled. Cabling took twice as long as expected. Originally, I was just wiring 12 points for Dolby Atmos, calling it a day. But then, like I said, I added 4 lines to each extra wall, I added extra Cat6, fiber optic, Toslink, 3.5mm aux runs on the other side of the room, which meant ordering more spools of cabling, waiting, and delaying the next stage of the build. Scope creep is real. So, like I said earlier in the video, lock in your provisions, your infrastructure early. Order more than you think you'll need. That was such a silly thing. I ordered the exact amount of cabling I needed, like 1 spool of cable to do all the Dolby Atmos runs, and I literally finished that spool exactly where I needed, and then I decided I needed more for other things. And it was like the cost of getting another spool wasn't worth waiting an extra week for. I just should have fronted that up front. But anyway, once the cabling's in, flooring. Now, the most underrated pain point, the floorboards arrived and I didn't install them straight away. I let them acclimate to the room for 2 weeks, and I'm really glad I did. 10% of the boards warped over 5 millimeters across their length. And if I'd laid them on the day they came here, they would have been buckled in the floor. So, before laying, make sure you sort your timber and grade it. I graded it into select, no knots, A grade 1 to 2 knots, B grade 3 to 4 knots. I used that to design a floor plan that distributed the quirks evenly across the room. And this is the fun bit. My wife is a trained pastry chef. So I asked her, hey, you're good at making cakes. I reckon you can trowel on the adhesive for the floorboards while I cut everything up. And apparently, icing cakes and laying floors share a similar skill set. She crushed it. I laser leveled every perpendicular joint to keep it clean and tight, and it turned out amazing. But it was just an interesting takeaway. I was lucky that I couldn't get to laying the floors straight away. Letting the timber acclimate made sure that I didn't put dodgy boards down. And I did order more than I needed for that at the advice of the suppliers as well. They said order an extra 10% for discrepancies and wastage. Then during that, I'm dealing with the back wall patch panels and custom touches. At night, I built the patch panels for the back wall. I fitted it all off, all the cabling, all the XLR, all the RJ45 back there. And all that custom XLR plates I talked about before, that's all stuff I was doing at night because it wasn't loud work. Making that glass door was really fun. That was the first time I'd done mortise and tenon joints, and I had a blast learning how to do that. I nailed it first go, and it's perfectly square, which is really cool. With that, we got to putting insulation in, put the floor boxes in the walls, and then strapped it all up. Once that was all strapped up, sanded and stained the slats. Actually, I got my dad to stain the slats because I hate doing finishing work. And then wrapped them up for protection so they were out of the way while we did other work. I built these floor boxes for the early reflections off the floor. And then all that was left was to upholster the wall, fit off all the slats and all the skirts, install the curtains, and solder the patch points once we fitted off the panels on the wall. The studio build wasn't fast, but it was intentional. Every layer was thought through, delayed, adapted, and all redone, and that's what turned it from a build into this beautiful space I've been enjoying for the last 2 weeks. And this gets us to the results. How does this acoustically measure this room? Well, plus minus 3.75 dB from 27 Hz all the way up to 20 kHz. Translation is surgical, and when something feels too much in the lows, in the mids, in the highs, guess what? It's too much. This room hasn't been lying to me, because not only does it translate in amplitude across the frequency spectrum, it translates across time. It's a good consistent decay time. So I'm going to just show you this here to explain what's going on. In this spectrogram, anything that is red, okay, so it's 83 decibels is our highest peak, okay, and everything, it has a 40 decibel range. So that drop off there of the waveform is 40 decibels down. So from an initial impulse, it takes an average of 200 milliseconds for the sound to decay 40 decibels. 40 decibels is a lot. And that happens consistently. You don't want to see any peaks or troughs in this response. That happens consistently all the way from 20 kilohertz down to about 40 hertz, and then it starts to lift up a bit, which is expected with low frequencies. And this is where it gets really interesting when you really want to dial into the detail. And this is something I learned from Drew over at Warp Academy. If we go to the filtered impulse response, we can actually filter it that's at 50 hertz, 1/3 filtering. Okay. At 50 hertz, it drops 40 decibels in 300 milliseconds. That's incredibly tight, given that is still within tolerance, as in still flat down to that frequency. And then we go to 63, there we go. We go to 80, 100, and then it just gets tighter and tighter. And then once you get above about what frequency do we get above? 160, everything is under 100 milliseconds on that. So we've got a really tight decay time and consistent decay time, if we go back to the spectrogram, across the board, which I'm really proud of. This is actually, whoopsies, what's that? Let's get that off. Back to the spectrogram. That is a wildly consistent result, especially against the overall graphing of this. And where is the waterfall? The waterfall plot up to 350 hertz is super consistent as well. So this is the amplitude, and that is across time. It is even, there's one little trough here, but even then it's only 3.75 decibels softer than the average overall signal, so it's not a great massive dip. So the results of this is a joy to work in. I achieved my acoustic goals. The infrastructure is incredible with all the wiring for Dolby Atmos. The extra inputs and outputs help me record clean audio for YouTube without having to drag interfaces onto my desk or cables across the room. I'm also testing out Sphere. It's a dedicated monitor controller, which I'm routing using on the desktop through my Antelope converters, which means if I go Dolby Atmos in the space, that might be my main central control hub. My other goal, did I finish this in 2 weeks? I absolutely did not. That was delusional. But what I did build over time with intention is a space I'm proud of. It sounds amazing. It feels clean. It works exactly how I need it to. What would I change? Well, I wish I'd run extra boxes, more cabling, more provisions for the surround left and right positions. Right now, those cable runs come from the front of the room's wall in those 2 floor boxes. And I realize that that means I'm going to have a cable run to the surround position there, which isn't super messy, but it just would have been cool to have a patch point right there. I can't do that now, but I've still got the infrastructure there to run the cabling, which is good. An unexpected win, the sheer curtains. I installed them for aesthetics and privacy, but during the day, I'm filming this at night, but during the day you'll see this in future videos. They are incredible light diffusers and a great soft light for filming video in here, which is really cool. Now, as a final thought, this build wasn't fast, it wasn't easy, and it was worth it. If you're planning your own studio, don't chase perfection on paper. Chase performance in practice. Plan well and make sure you're able to adapt to change during the process. Ultimately, you just want to build a room that serves your best work. And for me, I'm happy to have achieved that. I'm really happy I got to take you along this journey because this was something very special to me and marks a new sort of milestone in my career. And until next time, take care.